Hey, welcome. We're about to crack open a secret code. And the cool thing is, it's a code that's literally all around us, helping us solve puzzles and figure out how the world works.
All right, let's kick things off with a quick brain teaser. I'm thinking of a number. If you add 5 to it, you get 12. Go on, what's my number? You probably got it already, right? But what if I told you there's this super powerful system for solving exactly this kind of problem, no matter how tricky it gets? And that's it. The secret is algebra. Now, hang on, don't tune out. Forget about that intimidating math class you might be thinking of. I want you to think of it as a language, a special language designed to find missing pieces and make sense of things. So first things first, to learn any language, you gotta start with the alphabet, right? Let's dive into the basic building blocks of algebra. Okay, so what is algebra really? Well, at its core, it's just a language where we use letters, like X, Y, or Z, to stand in for numbers we don't know yet. It's a way for us to write down a problem even when a piece of the puzzle is missing. And in this language, you've basically got two main types of words. First up, you have constants. These are the numbers you know and love, like 5 or 100. They're fixed, they don't change. Then you've got variables. These are the letters, like X or Y. Think of them as placeholders for a number that we're trying to figure out.
All right, so we've got our alphabet down, constants and variables. Now let's see how we can start putting them together to build phrases, and then full-on sentences.
You see, in algebra, a phrase is called an expression, and it's made up of just 3 simple ingredients. You take your variables, you add in your constants, and you mix them together with the operations you already know: plus, minus, times, and divide. That's it.
Let's look at a classic example, 3x plus 8. This is just a fancy way of saying 3 times some unknown number plus 8. See, the x is our variable, the thing we don't know, and the 3 and 8 are our constants. It's a neat little phrase, but it's not a complete thought just yet. And you want to know why?
It's because it's missing the single most important symbol in the entire language, the equal sign. An expression like x plus 5 is just, well, a fragment. But the second you add that equal sign, like in x plus 5 equals 12, bam, it becomes an equation. It's now a complete sentence, and it's making a really powerful claim. It's saying the stuff on the left is exactly equal to the stuff on the right, and that's the key that lets us solve the whole mystery.
Okay, this leads us to the absolute #1 rule for solving these algebraic sentences. It's a super simple idea, but trust me, it's the key to everything. We call it the rule of balance.
I love this way of thinking about it. Imagine an equation is like one of those old school balancing scales. If you put something on one side, what happens? It tips over, right? To keep it perfectly balanced, whatever you do to one side, you have to do the exact same thing to the other. That one simple, beautiful idea is how we find our mystery number. So let's jump back to our first puzzle. X plus 5 equals 12. Remember, our main goal here is to get x all by itself on one side of the scale. So how do we get rid of that plus 5? Well, we do the opposite. We subtract 5. But, and here's the golden rule again, to keep our scale balanced, we have to do it to both sides. We subtract 5 from the left, and we subtract 5 from the right.
And what happens? On the left side, the plus 5 and the minus 5 completely cancel each other out, leaving just our x. Perfect. And on the right side, 12 minus 5 is 7. And just like that, there's our answer. The number I was thinking of was 7 all along.
Okay, solving these little number puzzles is pretty cool. But where algebra really shows its power is in solving actual real-world problems. Let's take a look at how we can become detectives and translate everyday words into the language of algebra.
Seriously, think of yourself as a detective. Word problems, they're just coded messages. And this table right here, this is your decoder ring. When you see a word like sum or increased by, you know it means to add. If you see product, that means multiply. And the big one, the word is, almost always translates to equals. This is exactly how you turn clues into an equation you can actually solve.
All right, let's crack a case. Here's the problem. Raju's father is 3 times as old as Raju. We also know his father is 45. The question is, how old is Raju? First step for any detective, identify the unknown. In this case, it's Raju's age. Let's call it X. Now let's translate the clue. 3 times Raju's age is 45. That translates perfectly to the equation 3x equals 45. Now, to solve for x, we just do the opposite of multiplying by 3. We divide both sides by 3. 45 divided by 3 is 15. So Raju is 15 years old. Case closed.
So, Now you've seen how it all works, right? But there's one last really important idea I want to leave you with. The secret language isn't just for math class or puzzles. Nope. It is literally everywhere.
I'm not kidding. You really don't have to look far to see it. It's the invisible code that's basically running our world. From the smartphone in your pocket to how your bank figures out interest, algebra is the silent engine making it all happen.
Just think about your day-to-day life for a second. When you're at a store trying to figure out a 20% discount, you're using algebra. Doubling a cookie recipe because you've got friends coming over. That's algebra. Trying to figure out if you'll make it to your appointment on time? Yup, algebra again. It's the logic behind your budget, your GPS, and pretty much every app you use. Take planning a road trip. You're probably familiar with this one. Distance equals speed multiplied by time, or D equals S times T. It's one of the most famous formulas out there. If you know any two of those things, you can always solve for the third one. It's a simple little equation that governs how everything moves. Or how about something as simple as going shopping? The total cost is just the number of items you buy times their price. That's a basic algebraic relationship you use all the time, maybe without even thinking about it. You're constantly solving for an unknown, whether it's the final bill or just how many things you can actually afford. So, what's the big takeaway here? The next time you're facing a problem, whether it's a little puzzle or a big real-world challenge, I want you to remember that you have the tools to figure it out. You can translate it, you can give it structure, and you can find that missing piece. You speak the secret language now. So my question for you is, what are you going to solve with it?